Well, we're late, 2 minutes too late. Hello, welcome to the big stage. I'm Falko, and thank you for voting for my talk. I held this to colleagues at least once, and I thought it might be interesting, especially after Mario's talk. He's up on the Berlin Droid booth. I'm taking one step further. He built little Android LED thingies. I, at one point, built bigger things that you can connect to with your Android phone. And this almost became our CI setup, where a phone was riding on a Lego train next to our access control receiving station, connecting, opening a door, but never fully. So, yeah. I want to talk about Agile hardware development, and I have no hardware background, and so I want to inspire you. If you don't have any hardware background, feel free to also do some hardware. This presentation is open source. If you find any typos, if you have improvements, go there, edit, submit a pull request. Thank you. Everything I show you, even though I worked with these companies, is public domain, so don't think I'm telling anyone's secret here. Quick history about IoT with Android. Some people might remember the Yo-Yo. I have it in my box of goodies. It was a board in cooperation with Google that you can connect via USB to your Android phone and then do blinking lights like Mario did. There was the accessory development kit, which was also a failure. You can connect your Android phone to an Arduino and do some communication. I don't think any real products ever got out of it. Also, the Yo-Yo was just a community project. Of course, Bluetooth Low Energy came around and everybody's doing Bluetooth. Everything is better without Bluetooth. A talk I held with Ronaldo 3 years ago. And then there's also the USB connection, which Mario talked about. And I think the only real product using it is DJI with their drones, so you can connect your phone to the controller and then see the live video in high speed. And so, but I would say also USB is a fail, because like, who connects their smart home via USB? Really, nobody. So connectivity, Bluetooth is there, Wi-Fi is there, NFC is there, USB is there, and actually USB is a good option maybe to think about. But now, why Agile? What is the point? And I copied this from the Agile manifesto. It's all linked in the slides. It's a markdown file, so no need to take notes. We want to iterate fast. We want to deliver fast and stuff that is working. We want to change directions quickly. Working software, working hardware. So we want to be moving fast and not be stuck on stuff. And we want to be simple. So stuff that you can also, I would say, apply to hardware development, because like you could have two-week sprints developing hardware, and it's really possible. Mario talked a bit about it. He was able to order PCBs, and if you pay extra, you can get them within a week, even from China. There's services in Europe that send them to you also. So the actual PCB development, you can go this fast. But let's do a little case study. I heard case studies are a thing. A friend of mine, also EMI student from University of Applied Science, he built this in his co-working space. So what it does, it solves a problem. When you go to the office, you need someone to answer the Gegensprechanlage, the doorbell, so that the door on the bottom ring like opens you. Now, you also don't want the thing to ring all the time if your colleagues are coming. So, and I can assure you that this was also built iteratively. So he started out just with the board and connecting it to the intercom. But eventually, he has this device ready, and he built a little input, the potentiometers, so he can actually put this on another intercom. So now the use case is you go to the front door on your phone, you authorize yourself, you ring the doorbell, the board intercepts your call, so it will not ring, it's silent, and then it will open the door for you. So really good. You could experience it in this little co-working space, and he's looking for Flutter people. And he took it one step further, like you saw it here, as a prototyping board. So this is the software development stage. And then he eventually made a real board from it. And if you look closely, you will find some similarities, like this thing and the input and the actual motherboard, so to say. So he made this open hardware so that maybe more people could use it. There's actual buttons. So I mean, you could just stop there and put it on your door, or you can actually learn a little bit about PCB design, or you can find someone to do it. This is not really hard stuff. Like, if you look at the connections here on the back, people who know their stuff, they laugh at this. So, and also here you see there's some errors that needed to be corrected. So, yeah, so a good example of agile hardware development. Good. I have more stuff. We'll try to cover the 20 minutes and then we can have questions. So of course, everybody says, ooh, hardware, that can't be done. I don't know things about hardware, but nobody knew about developing for Android. So we learned by reading the documentation and just went at it. Same goes for hardware. There is documentation for hardware as well. And you can read it, and then you can try it, and then either it works, it doesn't, you try again, and you're good. The tools are super approachable nowadays. There's online tools like Mario showed you. There's open source PCB designers. So it's super approachable. Sometimes you don't even need to design a PCB. I will show you this in a minute. Manufacturing has gotten super cheap and super fast, so you can really iterate fast. And I don't know, maybe somebody has other blockers, but I think this is already pretty good. So yeah, kind of news. There's two links. JLPCB is one of these Chinese manufacturers that can build your board and ship you 1 or 1,000 within a couple of weeks. Isla is one in Europe. Of course, there's open source hardware. It's called Open Hardware. There's a store where you can sell your open source hardware. It's called Tindy.com. KiCad is the PCB design software. There's many platforms, operating systems to choose from. There's a Raspberry Pi, pretty open. There's the new Raspberry Pi little thingy. There's the ESP platform with the ESP32, and you can write Python code. There is Nordic Semiconductors, who are also on the conference, and they also have little boards. And of course, there's YouTube with people explaining you how to build your own hardware, which is super helpful, especially when you're stuck at home. So just as to give you an idea, 2 years ago I literally bought business cards made from PCB, and they cost me 35 euros, which is pretty amazing, with DHL Express worldwide. I mean, that's pretty crazy, huh? They didn't do anything, but just to give you an idea, what is it, 20 business cards or something, super cheap. DHL Express worldwide. Now, of course, you're like, oh my God, I just have a PCB, what do I do? Of course, you might need to get your hands dirty, do some soldering. It's actually not that complicated. There's a million people on the internet showing you how to solder. You might need one of these, which is a soldering iron, which also has a little super hot air gun thingy. So it's like the hot air gun you might know from home, but it's really, really soft. So the hot air is really, really softly blowing out of it. And literally, and even the teeny tiny pieces, you can do by your own. And if you use the hot air gun, you're even like almost production level. You could literally solder them with the soldering iron. It's nothing to be afraid of. If you have shaky hands, there's ways to get your hands a little less shaky, or you have a friend who helps you, and there's maker spaces as well, so nothing to be afraid of. And then there's really cool stuff on the internet and out there that you can use to prototype hardware without getting your hands dirty at all. For instance, Tinkerforge, and I have a little bit of Tinkerforge stuff here. So how it works, it is this, this is frozen, 1 sec. Okay. Oops. So you have these boards, and they're stackable. So this red board, you see here, is a Linux computer. It has mini HDMI, it has USB, it has a power input, a micro SD card. So it's like a Raspberry Pi. I just connected a Wi-Fi antenna to it. And then there's this board, which is like an extension board. And for instance, you can buy a thermal camera module, and you can connect the stuff. And voila, you have your internet-connected thermal camera powered via USB. Tinkerforge is really, really awesome. All the hardware is open source, so if you like what you did and you build a product and maybe somebody wants to throw some money at you, you can go and take the open source designs of the hardware they provided, tell somebody to build a nice packaged version of it, and voila, you have a product. They have screens, any sensor you can imagine on the world. It's pretty good. And they have code for all platforms. I can try to show you some. You don't need to read this, but it's this much code, very bad, and you can get the thermal camera stream via IP over to your phone. And I'm inspired by Mario to do this via USB as well. And literally there's people taking these stacks and putting them into enclosures and building real products. So it is amazing. And also you can use them to understand the underlying like protocols and stuff. But you basically get Java code or like you get a jar to include. It's really amazing. Good stuff. There's also fidgets, another thing. It mainly connects via USB to your main computer, and then there is a service running you can connect to. And they also have a gazillion things to do. On the picture you see the I/O fidget, which you can use to detect maybe a closed window or something like that. Of course, everything connected with wires. But they're a huge and great resource if you want to get stuff going. And then there's the Raspberry Pi compute module, which is very approachable. It's not cheap, but it could actually get you going. As you know, Raspberry Pi quad-core Linux computer, pretty amazing. And there is an industrial version of it. So what does it mean, industrial version? First of all, they tell you you can buy this thing even in 4 years' time. So if you build your product, you want to make sure that you can get a replacement part in 4 or 5 years. So they have some promises. They have prototyping boards that you can use to take your idea, take one of these prototyping boards and actually make a product from it. The new compute module 4 has even gotten a huge, bigger community. And there's a million people now building little boards that you can adapt to. There is server rackable Raspberry Pi stackable things that you can buy. It's pretty good stuff. I have a link to a guy who's talking about this all the time. And how does it look eventually? Let's go back to my camera setup. So here's the inside of one of this product, actually one that I worked on. And like also here we were very modular, I guess clean architecture, you know. And in here is the compute module, and it looks like a computer RAM, but there's the actual Raspberry Pi Broadcom CPU. There's RAM and storage, and then you can build your own little hardware and plug it in, and voila, you have a product. And everything you know from Raspberry Pi development, you can use. It's like a little Linux computer. So if you or friends or your company knows how to manage computers and servers in the cloud, that's it. Ansible, whatever, you can put software on it. That's it. Tinkerforge also has a little adapter board for a Raspberry Pi. So instead of buying the red computer, you can also use the Raspberry Pi. So there's even some overlap in between. Oops. Let's see. We did this. This is super cool. I stumbled upon this as well. So imagine these programming studios for kids where you can place little bricks of things and they interlap like Legos. There's this concept, but for hardware. The company behind is called Gumsticks. It used to be called Geppetto. And it is really, really amazing. Literally, you can say, I want this CPU, I want power over Ethernet, I want a connector for my 20 LEDs, I want Wi-Fi. You put it all on the board. It will do all the hard work and make sure that you have the right power supplies connected to the right inputs and outputs and everything. And then you can put some money into the system, and they will manufacture it for you. And if you want to make your product go live to many people, you can give some more money to them, and then people can go buy the product directly with them. So they are basically taking the upfront cost, take them from you. You can, I don't know, Kickstarter them, and then they can purchase the board, or you can sell it. It's pretty cool, and there's some examples. The Gumsticks Jetson Mega Drive, for instance. I can order it, or I can open it, and it is copying the workspace into our workspace. And you can see there is a vertical USB 3 jack, and you can see the little components. And somebody built a NVIDIA Jetson board, so it's really that easy. And we actually ordered from this, so this is verified. It's not like they're faking it, but it's pretty cool. I don't have hardware from them, so nothing to show. Maybe just as an idea, you don't need to build your own hardware, maybe from the bottom up as well. Here we go. So this is also a product that could inspire you. And instead of being permanently connected to this Raspberry Pi, what is it called, the small one? It's the Zero. So instead of being soldered to the Zero, there's a little spring-loaded connections. Oops. And you can see here some more. So literally, this is just screwed on top of each other. The little spring-loaded connections provide the connection, and you've got a Raspberry Pi Zero powered display drive. So this actually is a PiESO. So I can select an image on this, and then when I plug it into a computer, that image will be loaded, and I can, I don't know, make my server boot from it. So you don't even need soldering, you just put stuff on top of each other. I did talk about NRF a bit. They're pretty good. Two of them are also around. They will talk about mesh today. They have a pretty good software library, and they tell you all about serial connection via Bluetooth as well. There's some stuff, if you are getting closer to the goal, you want to make sure that you could actually sell your product, mass production cases, but just look at the links. If you know where to get them, you can just go and ask them, and they're happy to sell you stuff. And that's it. Questions?